So section 4, chapter 4 is all about how to solve either exponents or logarithms. And in order to solve something, you need to know the opposite. So to eliminate exponents, you need to take the log. And we're going to use base 10 or base e, because that's what our calculator is able to use logs with, because of the bases plugged into the calculator. So when we take the log, what does that force us to use? Well, that forces us to use the log properties. So if I have an exponent that is unknown, I can bring it down in front using the log property number 3. If I wanted to eliminate logs, I need to exponentiate. In other words, I need to take and write it as an exponent. And then I know how to deal with exponents. So let's go ahead and look at an application. And because this says continuous rate, I'm thinking E or natural log for continuous. So investment that's growing at a continuous rate. And if you are reminded of the formulas, we had that A equals P e to the RT formula, and that was for compounding continuously. And I want to know how long it's going to take for this investment to double. So I really don't know what I start with. Let's just imagine that I start with $1,000. If it's going to double, it's going to be worth $2,000 in the end. E I know is 2.71828. The rate, well, we need to know how long this investment, the rate of interest. So this problem is actually missing the rate. So let's go ahead and say that it's going to grow at a rate of 5% compounded continuously. So now that I know my rate, your problems in the book will give you that rate. I'm going to raise it to the 0.05 and t for time. So that's where I get the PERT. So regardless of what I started with, when I divide it out, because now we're going to solve for that exponent, so I need to start to isolate it. This result, whether it's 2,000 doubling to 4,000, ends up being a 2. So it really didn't matter what I started with. However, the rate that was missing from the problem does matter. So I get e raised to the 0.05t. Okay, now I need to solve for that t. It is in an exponent form. So if I want to eliminate exponents, I need to take the log. Now, with the base e, I like to take natural log because they go together. So when I natural log the left, I'm going to natural log the right and use property 3 all at the same time. Well, the natural log of e is 1. I'm going to divide by 0.05, which was my rate. And now in my calculator, if I go ahead and plug in natural log of 2, so again, you've got to find that on your calculator here, natural log of 2, which is next to the 4. I need to close that up, and then I need to divide by the rate, which is 0.05, and it looks like it's going to take about 13.86 years. So approximately 13.86. So you'll have to do some problems such as this. Remember, when you want to get rid of exponents, go logging. When you get rid of logs, you want to exponentiate.